In this video, I will show you how to write and graph the equation of an ellipse, even if the center of the ellipse is not 0, 0. Here are a few things we know about the equation of an ellipse. We have to keep in mind that sometimes ellipses are stretched horizontally. This is called the major axis going the long way. So sometimes the major axis is horizontal, and sometimes the major axis is vertical. So the way the equation of an ellipse is set up, you will have x minus h squared over a squared plus y minus k squared over b squared is equal to 1. Now the h and the k are the center of the ellipse. Now a squared and b squared are constants. A is always the biggest number. Okay? A is the biggest. A is the distance from the center to a vertex. All right? The vertices are always the long way. So if you measure the distance from the center to a vertex, all right, that distance is A. If you go the short way, it's called a covertex. All right, so these are co-vertices. This is a co-vertex. And if you measure the distance from the center to the covertex, that is called B. So of course B is always going to be shorter than A. Now, if the bigger number is with the x squared term, then that tells you that it's going to be longer in the x direction. So a horizontal ellipse is always going to have the bigger number with the x squared term. So looking at this blue version, where the major axis is vertical, notice that I have the a squared with the y term. That's because the bigger numbers with the y means that the long direction, the a value, is going to be in the y direction. So for this problem, this a value from the center to a vertex is going to be here. And the b value, which is always the short way, is going to be here. And again, this is a covertex. And this is my b value. Now there's also something called a focus, which the foci always go the long way. So they will always be on the major axis, and they will occur inside of the ellipse in two places, like for example here and here. Now the distance from the center to a focus is given by the variable c, or the constant c. So we will also have the c in here, okay, that we'll have to deal with. All right, there are two foci, just like there are two vertices and two covertices. All right, but this distance right here is going to be given by c. It turns out that for an ellipse, the relationship between the a, b, and the c is this. C squared is always equal to a squared minus b squared. Let me just throw in one more thing while I'm doing this. There is something called eccentricity, all right, which I will use the variable e for eccentricity. It has to do with how far an ellipse is, or any conic section, away from being a circle. But the eccentricity is always c over a. So basically, you need to memorize everything on the screen right now. Now we are being asked to write an equation given vertices, co-vertices, or foci. This is going to be very easy. We're told it's an ellipse. So look, the center is going to be 0, 0. I know this because looking at the vertices, it's 9 to the left, 9 to the right. That means 0 would be in the middle. Looking at the co-vertices, all right, it's -7, that's down 7, up 7. The middle would be 0, 0. So because I know that the center is going to be 0, 0, then I know that it's going to be x squared over something plus y squared over something. And it's always equal to 1 for an ellipse. Now also, they gave me the vertices. So because the vertices are positive and -9, that means that the a value is 9. And if a is 9, that means, okay, I'm saying this backwards. The a value is 9. That means that a squared must be 81. Now, how do I know whether to put the a squared, the 81, under the x squared or under the y squared? Well, look, each one of these points are an x and a y. So since this 9 is an x value, then I'm going to put the 81 with the x term. So the 81 goes here. Okay, now the co-vertices tell us what the b value is going to be. So the b value is going to equal 7, which means that b squared is equal to 49. And again, look at this thing. I've got x comma y. This 7 is a y value. So that tells me that the b squared, the 49, is going to go with the y term. So that's it. There's the equation for number 5. All right, number 6 will take a tiny bit more thought because the center is not going to be at 0, 0. To help us out, let's do a quick sketch. Okay, so we have a vertex at 1, -9. All right, so here's 1, and here is -9. So here is a vertex. We have another vertex at 1, 15. So 1, 15, all right, that's like right here. Okay, so 1, -9, 1, 15, all right, vertex. Now let's talk about the co-vertices. The co-vertices are at -4, 3. Okay, so, all right, so this is -4. Okay, so -4, 3. All right, and 6, 3. So these are my co-vertices. So what I'm doing is I'm trying to find the center. So look, if I draw the major axis, it's going to be like this. And if I draw the minor axis, it's going to be like this. Okay? Now, what is the point right here at the center? Well, the x value is 1. Like these 2 points. The y value is 3, like these 2 points. So the center is 1, 3. Because the center is 1, 3, that tells us the numerator of our equation. Okay, so we're going to have x minus 1 squared because of the x-coordinate of the center. We're going to have y minus 3 squared because of the y-coordinate of the center. And of course, the equation of an ellipse is always equal to 1. So all we need to know now is the a squared and the b squared. Well, let's see. The a value is going to be this distance right here. This will be my a value. Okay, it's the distance from, let's see, so here we have a height of 3, a y value of 3, and it goes all the way up to 15. So what's 15 minus 3? That's 12. All right, so the a value is 12. Okay, that means that a squared is 144. Now this is in the vertical direction, the y direction, so I'm going to put that 144 with the y squared term. Okay, now I need the b value. The b value is right here. Okay, the distance from the center to a co-vertex. Okay, the x value is at 1, and then it goes from 1 to 6. So what is 6 minus 1? Of course, that is 5. So my b value is 5, which means that b squared is 25. This is in the x direction, so I'm going to put this 25 in the x squared term. So this would be the equation for number 6. All right, let's do one more problem. All right, I'm going to sketch this one as we go. Okay, the vertices are at positive and negative 12. Okay, so let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, do I even have enough space for that over here? Better make it longer. 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12. So these are my vertices. All right, here and here. Okay, 12 comma 0 and negative 12 comma 0. Notice that these are in the x direction. So I already can tell you something about my equation. First of all, you can see that the center is right here at 0 comma 0. All right, it's 12 to the left, it's 12 to the right, and the points are right on the x-axis. Since the center is 0 comma 0, I know that the numerators will be x squared and y squared. Okay, and it's going to have to equal 1. Now this is the a value. The distance from the center to a vertex is the a value. So a is 12, which means that a squared is 144. Because this is in the x direction, the 144 will go in the denominator of the x squared. Now I just need the b squared. But to find that, I'm going to need the b value. Well, let's do some calculations. We know that c squared is equal to a squared minus b squared. Okay, we know that a squared is 144. The foci tell us what the c value is going to be. Because the foci are plus or minus 10, that tells us that the c value is going to be 10. All right, it's the distance from the center to a focus. All right, basically the foci are here and here. Okay, so that's the c value is 10, which means, of course, that c squared is 100. So when we do our c squared equals a squared minus b squared, c squared is 100, A squared is 144. And we are looking for B squared. All right, if I add B squared to both sides and subtract 100 from both sides, basically I'm moving B squared to the left and I'm moving 100 to the right. That's going to give me B squared is equal to 144 minus 100. All right, I move that over there and I move that over there. So that means B squared is equal to 44. Okay, I'm not going to do the square root because I want B squared. So that tells me that the 44 is going to go right here. And that's it. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.